Hey guys, welcome back. This is my video on galvanic cells. If you've seen my previous videos before, you may know that I made a galvanic cells video, but I took that off my channel because I did not think that was my best work or my best quality. So here's a different video, a new video on galvanic cells, and I hope you like this one better. So first off is, what is a galvanic cell before I start anything else? A galvanic cell is a device which uses a spontaneous redox reaction. And spontaneous, if you don't know what that means, is that it is a reaction that doesn't require you to add any energy to it. It will do it on its own. It produces its own energy, where chemical energy is turned into electrical energy. So it produces its own current, right? What does that mean? So it doesn't require me to add energy to it. It doesn't require me to add something or do something where like mixing it or do putting my own energy into it, so that way the current is produced to do the work, or the spontaneous reaction to do the reaction to turn the chemical energy into electrical energy. And chemical energy is that electrical energy is produced, is what we call electricity. So when your battery in your Duracell is no longer working, is because your galvanic cell or your alkaline battery is lost all of its potential to do the spontaneous redox reaction. So get new batteries. So there are two parts in every galvanic cell, the anode and the cathode. The anode is known as the half part of the reaction, where it is the reducing agent, and the anode is oxidized. It's the reducing agent and it is oxidized. It is not the oxidizing agent, it is oxidized. My friends in my previous who watched my previous video said that I got this wrong. So I'm making you realize right now that reducing agent is oxidized in the chemical process by losing electrons. Sorry, losing electrons. This is my original work and I'm correcting myself on this. Those of you who've heard me, I'm correcting you as well as I'm correcting myself. It is losing electrons. It is the reducing agent and it is oxidized, but it is losing electrons. The cathode is the other half of the reaction, where it's the oxidizing agent and it is reduced by gaining electrons. So as you can see, that's where my friend said I was wrong, and I copy pasted it, and I wanted to make sure that in this video I show you that what I wrote was wrong and that it is the losing of electrons, not gaining. Here, the cathode is where you gain the electrons. So what am I saying in this is that every galvanic cell has this anode right here. So in this case, in this image, my zinc is going to be my anode. Here, a zinc nitrate and copper nitrate with zinc and copper metal. So this here is going to be the anode. This here is going to be the cathode. The electrons are traveling from the anode and are going and piling up on the cathode. And what's important about this is that you should always realize that never get this confused, because when I took my tests and things like that, I got this confused completely. And it was really bad. So to remember this, here's a saying. Leo the lion says grr, which means lose electrons in oxidation, gain electrons in reduction. So the element or the metal that is oxidized, it is losing the electrons, while the metal that is gaining the electrons is reduced. Another saying would be, a red cat ran from an ox. anode is where the oxidation occurs. Reduction is where the cathode occurs. So depending on what you have confusion understanding like me, this is the two best systems to remember. Now, if you want a galvanic cell to continuously flow, continuously go on, you need to know that it needs a salt bridge. Now, based on prior experience with tests and exams in AP Chem, so if you're an AP Chem student or you're going to take AP Chem sooner or later, you need to know this. A galvanic cell always needs a salt bridge or porous disc. If you ever heard porous disc and you don't know what it means, it's just a salt bridge. A salt bridge is basically it's just a device which allows the flow back and forth continuously between two solutions without mixing them. It is important for the electron flow. Electrons will not flow without it. And to correct those who've in my class got this wrong on their test, they do not move the actual electrons themselves. They maintain the charge balance. So something right here to know is that here is some suspended gel of NaCl, and usually right here is some cotton or something to stop the fluid or the gel from spilling out into the solutions right here, the zinc nitrate and the copper nitrate. So to note about this is that the Na, the cation, goes to the cathode as it spills, because as much as I said that this won't spill, the cotton will absorb most of the gel, but a few ions from the NaCl will drop into the solutions based off attraction. And the cation will go to the cathode, in this case, which is Na plus, and the anion will go to the anode, which is the Cl minus. Why is that? Is because, like I said before, the anode loses electrons while the cathode gains electrons. What happens usually to a solution or a metal is that when they lose electrons, it becomes more positive. It becomes positive right here, because the electrons are what give it its negative charge. So when it loses that, it's completely gone. Now, what happens to a substance when it gains electrons? The exact opposite. It gets a negative charge. So if you take chem or AP chem, the basic thing for you guys to know is that the negative charge of the Cl is attracted to the positive charges of the zinc and the zinc nitrate here, while the Na plus is attracted to the copper in this case. Now, a thing to note is that this solution is full of copper 2 plus ions, and this is zinc 2 plus ions. Now, the attraction for the Cl to the zinc and the Na plus to the copper is caused by this. When something loses electrons, as it loses electrons, it kind of disintegrates. Because if you know what a metallic bond is, this might help you. Because in a metallic bond is basically the metal plus ions. They're just metal plus ions that are attracted to each other because of a sea of electrons. A sea of electrons. So when those electrons are just going and they're leaving, the ions break apart because the metallic bond is a very strong bond, but only because of the electrons. And when those electrons leave, there's nothing for those metal ions, those metal positive cations, sorry, the metal cations, they repel each other. So that's why they say this is oxidized, because it loses electrons and it becomes zinc 2 plus ions. It becomes zinc 2 plus ions here. While in the copper, the exact opposite happens. The copper 2 plus ions here are so attracted to the heavy sea of electrons that are coming in that they just start forming copper metal ions again. They just leave and they start getting attracted to the negative ions. The neg and start forming like extra like metal here. That you might see that in a reaction is that the cathode gets bigger while the anode gets smaller. So you might see some like a little bit of extra metal right here. So to take that off, that and even with those extra ions coming in and making an attraction with the sea of electrons, these ions, it still has a negative charge, which is why the Na plus from the NaCl is still attracted to it. Now you may wonder, what does the salt bridge do? The salt bridge maintains the charge flow, which means that any at any given point in time, it would be maybe like after 2 minutes or maybe even 2 seconds, the galvanic cell will stop because eventually this will become positive and this might get positive, and then eventually both of them will have equal charge. They don't need each other anymore. They're like, okay, I got enough electrons, you got enough electrons, we're both good. This salt bridge makes sure that more Cl negative ions are there and more Na plus ions are there to give the positive charge and the negative charge for the anode and the positive charge for the cathode, to continuously get that flow to occur. Because if you've noticed in an AP Chem exam or anything, is that if you see a voltmeter and it says that it's 0, like a voltmeter, you might see a voltmeter attached to a voltmeter, and you see no salt bridge or anything, you should automatically know at that moment that it is because of the salt bridge. Because after 2 seconds, that galvanic cell will stop. This salt bridge is why the galvanic cell continues, which is why your alkaline batteries continue. So remember that always. This is why the salt bridge is important. Because without the salt bridge, there would be no continuous flow of charge and the galvanic cell will stop. And your alkaline batteries won't work even. So why am I saying an alkaline battery continuously? Is because an alkaline battery is an example of a galvanic cell. Oh, and BTW, one more thing. If you never hear the word galvanic cell, but you hear the word voltaic cell or electrochemical cell, sorry, I wrote over that. They're all the same thing. When I heard of voltaic cell or electrochemical cell or even galvanic cell, I had no idea. I thought there were 3 different types of cells. They're all the same. So if you're taking the AP exam or you're taking anything related to chemistry and you have to learn galvanic cell, remember this, okay? They're all the same. If you hear electrolytical cell, that's a different story. That's different. So thank you for watching this part 1 of galvanic cells. As I was recording this, I thought I might need a part 2 because galvanic cells are kind of hard to understand at first, but once you get the hang of it, you'll understand. It took me a while too. So I hope you guys like this video. I'm also going to be posting a part 2 soon, and I hope you have a wonderful day. Bye, guys.